All right, so this is the last part of lesson 4. This is the part where we review a few things that we've learned so far. So we'll go through this fairly quickly. We're not going to do all the questions because it's pretty clear what we're doing with the first few examples. These are the questions that we did on our last homework. If you were in class, we would have gone over these and just checked to make sure we knew the answer. Also, what's on here is there'll be a link to the next Math Antics video, and we'll be watching that in class as well if we were here. So again, you can just check that out when you get a free moment to do so. All right, so our warm up here is they want us to solve 143 times 26. Kids in class were given graph paper so that they keep everything in the proper place value, but we're just going to do it right up here and get started. So remember, let's start with our ones. Our ones because our 6 here is in the ones. So 6 times 3 is, so we start with our ones place, our 4s and our 10s, our 1 is our 100. So start with the ones. That gives 18. Can't put 2-digit number in a place value slot. So 6 times 4 is 24, plus the 1 is 25. And 6 times 1 is 6, plus 2 is 8. But again, that's actually a value of 858. So place value does matter. Before we go on and start multiplying by the tens place with the 2 and the tens, which makes that a 20, we cross out our regrouping symbols there, and then we start with a 0 here with our x out. Because again, everything we're multiplying is actually by 20, so naturally there'll be a 0 at the end of each one, and this just saves us some time. 2 times 3 is 6, 2 times 4 is 8, 2 times 1 is 2. I still like to put a plus symbol there so kids don't get confused by what operation they're doing. Let's start with our ones. We have 8. 5 plus 6 is 11. Carry our 1. 8 plus 8 is 16. Plus 1 is 17. And 2 plus 1 is 3. So that gives us 3,718. It says to do one other method, but I really would just want to focus on the standard algorithm at this point. So we'll just stick with that. All right, notes start on page 71. Again, this is a video, so you can rewind it, fast forward, pause it. I do go pretty fast when I record them, but you guys can always pause them if you need to. All right, we're going to skip this one because it's already solved for us. And we're going to start with this word problem at the bottom of the page, number 1. A certain washing machine uses 29 gallons of water for each load of laundry washed. How many gallons of water would the washing machine use for 156 loads of laundry? Show your work. The first thing we have to decide with a word problem is what operation we're going to be doing. Now, it kind of makes sense that this is a multiplication lesson, that we do multiplication, but I'm still going to write multiply up here. Now, some word problems will use different operations during the same problem, but this is just straight up multiplication. And the numbers we're using are 29 gallons of water for each load, underline that, and 156 loads. So naturally, down here, we'll have 156 multiplied by the 29 loads. And we'll start with our ones place. Our 9 is in our ones. And we'll start with multiplying by the number that ones. So 9 times 6 is 54. 9 times 5 is 45, plus 5 is 50. 9 times 1 is 9, plus 5 is 14. And let's cross off our regroups. Let's bring our placeholder down here, and we'll focus on multiplying by our 2 that's in the tens place. So we'll do 2 times 6, which is in the ones, that gives us 12. 2 times 5, which is in the tens, which gives us 11. 2 times 1, which is in the hundreds, which gives us 2, plus the 1 is a 3. Put my addition symbol there. We'll add up our ones column first, our tens column, our hundreds column, and our thousands column. Whoops. Sorry, I messed that one up. and get ahead of myself there. So you can do 4,524 gallons of water for doing that many loads of laundry. All right, let's turn the page. And right away, I want you to go ahead and cross off number 2. The problems we're crossing off, they're good problems. They're just ones that I don't want to confuse us with what we're trying to get at here. And let's do number 3. Now, number 3, if we're not careful, can turn into a lot of work. And sometimes we want to look at word problems and see how we can do them the quickest way possible. So let me just read off the problem first before I explain. All right, Raquel can type 63 words every minute. Rick can type 73 words every minute. How many more words can Rick type than Raquel in 135 minutes? So right here, that how many more words, I want you to write the word difference above there. And when I talk about difference between two numbers, we're talking about subtraction. So sometimes a kid would see this and be like, all right, well, I'm going to do multiply 63 times 135, get an answer, type Rick's in, which is 73 times 135, get that answer and find the difference. Or before we even get into that, let's try this. Let's look at the difference between 63 and 73. So 73 minus 63, that gives us 10. And when we see 10, that's a good thing because we're multiplying by 10. It makes our multiplication really easy. In fact, we know that both of them typed 135 minutes, and the difference between what they typed was 10. So let's multiply this by 10. And we learned the other day, just multiply these together, which is pretty easy. Any number by 1 is that number. And then bring your 0 over, and it's going to be 1,350. And that's how many more words that they can do. Jared chose B as the correct answer. How do you get the answer? What he might have done is he might have multiplied them, found the difference, and added the answers together. All right, so let's go on. We're going to do number 4, top of the next page. This is another one, just very similar to the last one, except let me show you another difference. I'll read the problem first, though. Mrs. Katie constructs a cube with 216 magnetic blocks. As shown in the picture there in your book. Students in her 2 classes will each make an identical cube. There are 20, so all their cubes will have the same amount of blocks since they're identical. There are 28 students in one class and 25 students in the other. How many magnetic blocks does she need for all her students? So she could multiply 28 times 216 and 25 times 216 and add those totals up. Or we're going to do the opposite of what we did with the last problem. Let's add up the total number of students she has all together. 8 plus 5 is 13. 2 plus 2 is 4 plus 5. So 53 total kids. Each kid needs 216 blocks to make that cube. So before she orders all this stuff, she needs to figure out how much she needs. So let's start. Start by multiplying by the 3 in the ones place. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6. Now we'll multiply by the 5, which is in the tens place, which means we have to create a placeholder and get rid of the regroup we're going to use for the first step. 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. And 5 times 2 is 10. Put an addition symbol down there to remind you what you're doing, which operation. Add up our ones. Here's our tens. Add up our hundreds. Here's our thousands, and here's our 10,000. And she will need 11,448 total cubes. The beauty of having multiple choice is you can see if you got the exact answer, which we did. And let's do 5, and that'll be the last one, actually. Let's do number 5 here. And we're going to skip the rest after this. So let's do 5. What are the values? And I thought this is really important. So what are the values of the regrouped amounts in the multiplication below? Circle these right here. Those are our regrouped amounts. And I'm just draw a little arrow. And this is to help us understand that when we're regrouping, we're not bringing over like single digits. Those numbers have different values than what it seems. They're a lot stronger, a lot bigger, more powerful than they seem. But let's talk about this 3 right here. So that 3 is actually 3 tens. So that value is 30. This 2 is actually 2 hundreds. So the value of that 2 is actually 200. And this 3 is in the thousands place. So that's actually worth 3,000. So the reason that the standard algorithm works so quickly is because the values of the numbers are actually bigger than what they seem. And this kind of helps point that out. So like I said, you can cross off 6 through 9. They'll be here on my slide presentation, but I just want to get to the work. All right, so in Schoology, you'll have a workbook page called Multiply 3 Digits by 2 Digits, which has a graph. Now, I only want you to do questions A through F. So do half of the questions and submit that through Kami. But best thing to do is use graph paper to help you with that. But get a hold of me if you have any questions, and I'll be certainly sure to help you out.